This is a lesson for 13-5, day 1, which are more word problems. Yesterday, we did squares and rectangles. These are for your projectile problems. What we're talking about with a projectile is, think about something like a rocket, all right? Think about a rocket starting from the ground, going up in the air, and then landing back on the ground, all right? Notice the shape that it forms here. The shape that it forms is a parabola, all right? That's what we're dealing with today. We're dealing with parabolas. So this first question says, physics tells us that the altitude h in feet of a projectile t seconds after firing is h equals negative t squared plus, this is the initial velocity, all right, plus the initial height, where v is the initial velocity in feet per second and h is the altitude in feet from which it is fired. If a rocket is launched from a hilltop 2,400 feet above the desert with an initial upward velocity of 400 feet per second, then when will it land on the desert? All right. Now, this sounds very complicated, but it's not. It's actually pretty straightforward, pretty easy. So look at this equation. All right, look at this equation. And it says that it is launched with a velocity of 400. This term in the middle, your x term, that term in the middle is your initial velocity. So this is your 400 in your equation. That's going to be your 400t. All right, we're not using x, we're using t. Notice that it even says t squared there. And your 2,400 is when it's launched, if a rocket is launched from a hilltop 2,400 feet. So it's basically being launched off the side of a cliff, all right? So this is going to be your plus 2,400. This is a super important thing. Make sure you're listening right now. This is a super important thing because this is going to change from question to question to question. What we want to know is when it will land on the desert, all right? So you have to think about this as we're starting from launching up here. We're starting launching from this distance is 2,400 feet above. All right, this is our little rocket. All right, I'm just going to draw like a little arrow for our rocket. But we're starting on a cliff, and that is 2,400 feet above the desert. Here's the desert at the bottom. So the desert, we're starting from launching here, we're going up, and then we're landing all the way down here at the desert. That desert or the ground, all right, in most of the questions it says, how long does it take to reach the ground? All right, that's going to equal 0. That's going to be very, very, very important for our questions today. Anytime it says that it's landing on the ground, it's going to be set equal to 0. So here's our equation, and we're going to put it equal to 0. So this is our equation right here, negative 16. We're going to have 0 equals negative 16t squared plus 400t, because that's our initial velocity, 400t, plus our initial height, which was 2,400. So all that you're going to do is use the Pythagorean theorem. Now, again, you could factor it using parentheses, but with this negative 16 out in front, I would not suggest doing it that way. Just use the quadratic formula. It's a lot easier. So we have negative b, or negative 400, plus or minus the square root of b squared, so 400 squared, minus 4 times a times c. I forgot my 4. All over 2 times a, 2 times negative 16. Be very careful. There are a bunch of people that I helped on yesterday's homework that forgot this 2 times the a part. All right, you have to look at that a part. It's negative 16 in this question. A lot of people forgot about that yesterday and just put a 2, and then we're getting the wrong answers. So again, what we want to do is we want to type this part right into the calculator underneath the square root. So we have negative 400 plus or minus. When you type that into the calculator, you get 313,600 Now, don't panic. That is a perfect square all over negative 32 when we multiply the bottom part. So the perfect square of that is 560. So we really have negative 400 plus or minus 560 over negative 32. This is where we want to split it into two. Now, I can't go any lower on my screen, so I'm going to go up and over here. So we have negative 400 plus 560 over negative 32. And we have, I'm going to go over here, we have negative 400 minus 560 over negative 32. We're not going to put things in simplest radical form today. We're going to figure them out as decimals, all right? Because what we're talking about today is time, all right? What we're figuring out is the time that it took to launch from the hilltop here all the way down to the desert. So we're figuring out this would be 160 over negative 32, which gives you negative 5 as your answer. Could it take negative 5 seconds? Does negative time make any sense? Negative time does not make any sense. So what we're going to do is we are going to reject the negative time. You can't have negative time. So we're rejecting that negative answer. On your Regents exam, you have to cross it out and write down that you're rejecting the negative time. Over here, we would end up with negative 960 over negative 32, and that ends up being 30 as our answer. 30 is our answer, all right? You don't have to sub it back into anything like we were doing yesterday with the squares and the rectangles. It's just 30 seconds, all right? 30 seconds is our answer. But just like yesterday, we have to reject the negative answer because that doesn't make any sense. Take a look at the next one. The Empire State Building is 1,250 feet tall. If an object is thrown upward from the top of the building at an initial velocity of 38 feet per second, its height s in s seconds after it is thrown is given by the function blah 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 blah. How long will it take to reach a garbage can that is 3 feet tall? So what we're doing is, here's our Empire State Building. This is my lovely drawing. All right, here's our Empire State Building. We're throwing it off the top of the Empire State Building, and it is landing on a garbage can that is 3 feet tall. So unlike the previous problem, and this is super, super, super important, unlike the previous problem where we were throwing it to the ground, this one, we're making it land on the garbage can that is 3 feet tall. So we're not going to set it equal to 0. We're going to set this equation equal to 3 instead. So we're going to have 3 equals negative 16s squared plus 38s plus 1,250. Now, just like we did in previous sections, to do the quadratic formula, you have to have it set equal to 0. So if you have this set equal to 3, we need it set equal to 0 first. So you have to subtract 3 from both sides. So now we have 0 equals, which is what we want to do the quadratic formula, equals negative 16s squared plus 38s plus 1,247. So now we can do the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, 2 times negative 16. When we type this into the calculator, 38 squared minus 4 times negative 16 times 1,247, we get 81,252. Now, again, all these problems are set up nice and neat, so that actually is a perfect square all over negative 32. This one actually is not a perfect square. I just lied. Negative 38 plus or minus, when we take the square root of this, when you type that into your calculator, you get 285.0473645. You're just going to type out that whole thing, whatever appears on the calculator when you do second and square root of 81,252. All right, and that's over negative 32. This is where we're going to split it. So split it, split it. So we have negative 38 plus that big long number, 285.04, blah, 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 blah. I just don't have enough room to write it, over negative 32. And we have negative 38 minus blah, 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 blah number, all over negative 32. So when we go to do this, all right, we need to type this into the calculator, negative 38 plus this number divided by negative 32. You get negative 7.72 approximately. Now, again, what we're finding is we are finding time. Time can't be negative. So we have to reject this negative number, all right, because time can't be negative. We can't have negative 7 seconds. Then we have negative 38 minus this number divided by negative 32, and we get 10.095 approximately. That is our answer. All right, so it's going to take 10 seconds when you throw this object off the top, and it goes all the way down, 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 till it reaches the height of the garbage can at 3 feet. It's going to take a little over 10 seconds. On your homework today, it will say specifically what to round it to. Let me show you one more, and that's it. A ball is thrown up in the air from the ground. Anytime it says the ground is 0. Its height is given by that equation, where t is the length of time in seconds that the ball has been in the air. When will the ball hit the ground? So in this one, we're starting off at the ground, throwing it up in the air, and landing back on the ground. So it's given this equation. So since it's landing on the ground, we want to set it equal to 0. So we have this equation. And all we want to do is the quadratic formula again. Negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a, 2 times negative 16. Type this part into the calculator, 64 squared minus 4 times negative 16 times 3. So we have negative 64 plus or minus the square root of 4,288 all over negative 32. Take the square root of this number. Again, this one does not come out to be a perfect square. It is approximately 65.482. Divide by negative 32. So now we want to split it. So negative 64 plus that decimal, and negative 64 minus that decimal, all over negative 32. Type those right into the calculator. All right, this plus this, hit equals, and then divide by negative 32. This minus this, hit equals, and then divide by negative 32. So just make sure that when you're typing it in, you have to, if you type it into the calculator all at once, you have to put parentheses around here. All right, I would hit equals first and then divide by negative 32. If you type it in as one big long string, you will get the wrong answer every time, because the calculator will follow order of operations and it'll do the dividing first before it does the adding. We have to do the adding first. So make sure that you either type it inside parentheses, that top part of the fraction, or hit equals after it. On this side, we get negative 0.0463. On this side, we get 4.046. Again, we cannot have negative time. So we're going to cross this one out, rejecting our negative time because we can't have negative time. So this is our answer. All right. That's how long it takes to start from here, throw it up in the air, and land down on the ground. Remember, the most important thing today is when it says that it's landing on the ground, it equals 0.